In the year 1612, when Galileo Galilei looked at the planet Jupiter through a telescope, he may have accidentally discovered a new planet, although he had no idea at the time. It wouldn't be for another 300 years until astronomers found what Galileo had missed, and the process of discovery was unlike that for any other planet. Today, it remains the most distant and least explored planet in the solar system. Learn more about Neptune, the solar system's most distant planet and the eighth planet from the Sun, on this episode of Everything Everywhere Daily.
Does your health routine for the new year include eye care? Well, now that you can use your renewed vision benefits, it's easy to add it to the routine. Visit pearlvision.com and schedule exams for the whole family. They work with all major vision plans, including iMed, and they'll cover your cost of insurance copay or eye exam. Valid prescription required. Valid at participating locations. Restrictions apply. Taxes extra. See store for details. Ends 3/31/2023. Exams available at the independent doctor of optometry at or next to Pearl Vision. Some doctors employed by Pearl Vision.
Are you fascinated by unexplainable crimes, conspiracies, and fringe culture? Well, step into the crawl space. From tales of survival and deepfakes to synchronicities and cryptozoology, Crawl Space is a podcast that brings you weekly stories of the mysterious, harrowing, and bizarre. Search Crawl Space wherever you listen to podcasts. Crawl Space, where crime meets culture.
Neptune doesn't get a lot of attention. It's technically the furthest planet from the Sun, but that was only because Pluto got demoted. The story of Neptune, as far as this episode is concerned, starts with its discovery. Neptune is, on average, 30 astronomical units from the Sun. An astronomical unit is the average distance from the Sun to the Earth. Because of its distance, you can't observe Neptune with the naked eye. That means, despite thousands of years of gazing at the night sky, humans had no clue that Neptune existed until the advent of telescopes. As I mentioned in the introduction, there's a good chance that Galileo had actually observed Neptune without even knowing it. When Galileo was taking observations with his telescope in 1612, he kept detailed notes about what he saw. His sketches of stars made during observations of Jupiter on December 28, 1612 and January 27, 1613 correspond to where Neptune would have been on those dates. However, he would have had no clue that what he was looking at was a planet. It looked just like a star, and Neptune would have been in retrograde at the time, so it would barely be moving relative to Earth. The discovery of Neptune really began with the discovery of Uranus in 1781. By 1821, astronomical tables had been produced for the orbit of Uranus, and it soon became obvious that something was influencing its orbit. The only thing that could possibly influence the orbit of a planet that far away was another planet even further away. French astronomer Urbain Le Verrier and British astronomer John Couch Adams had independently calculated the orbit of this other planet and have both been given partial credit for the discovery of Neptune. However, the first observation of Neptune was by the German astronomer Johann Galle on September 23, 1846. It wasn't technically the first observation, but it was the first observation by someone who knew that they were looking at a planet. So Neptune was the first and only planet discovered before it was actually observed. Once Neptune was observed, its largest moon, Triton, was discovered just a few weeks later by the British astronomer William Lassell. The naming of the planet was a bit contentious. Normally, the person who discovers an astronomical body gets to name it. However, the discoverer of the planet was up for debate. Galle proposed the name Janus. The English astronomer James Challis, who had actually observed Neptune without knowing it, suggested the name Oceanus. It was Urbain Le Verrier who proposed Neptune. Actually, he tried to get the planet named Le Verrier after himself, however, this was rejected by pretty much everybody outside of France. Ultimately, Neptune was universally accepted as it fit with the convention of naming planets after gods in Greek and Roman mythology. Neptune being the Roman name for the god of the sea, the equivalent of the Greek god Poseidon. In other languages, the god of the sea theme has stuck. In Chinese, Japanese, and Korean, the name of the planet roughly translates to the Sea King star, and in Greek, it's known literally as Poseidon. In almost all languages, the planet is referred to as some sort of sea god or sea monster, even if the actual word Neptune isn't used. The name of the moon Triton wasn't proposed until 1880 and wasn't formally adopted until 1949 when a second moon was discovered, which was named Nereid. With optical instruments, there were basic facts about Neptune that we could determine from Earth. The planet takes 164.8 years to orbit the Sun, and a day on Neptune, the time it takes to rotate about its axis, is only 16 hours, 6 minutes, and 36 seconds, and the tilt of the axis is about 28 degrees. That means that a year on Neptune is 89,666 Neptunian days long. When Pluto was discovered in 1930 and was assumed to be a planet much larger than it really was, it took over the title of furthest planet. However, because the orbit of Pluto is so eccentric, there was a 20-year period from 1979 to 1999 where Pluto was closer to the Sun than Neptune was. Neptune is categorized as an ice giant, as opposed to a gas giant like Jupiter or Saturn. The only other ice giant in the solar system is Uranus. What separates Neptune and Uranus from Jupiter and Saturn are the composition of their atmospheres. Gas giants mostly consist of hydrogen and helium. Ice giants have atmospheres mostly consisting of volatile compounds with higher freezing points, such as water, ammonia, and methane. Neptune doesn't have a solid defined surface. It consists mostly of gases and liquids. The water on Neptune is believed to be what is known as a supercritical fluid. It's below the freezing point of water, but the pressure is such that it doesn't behave as a solid. Neptune is 17 times more massive than Earth, but only 1/19th the mass of Jupiter. The diameter of Neptune is about 8 times that of Earth, and despite being much larger, it turns out the gravitational pull of Neptune would only be about 11% greater on Earth, assuming you could stand on the surface, which you can't because it's liquid. All of these basic facts about Neptune, which I just listed, are things which could be discerned from the Earth and from analysis of its orbit. There was a whole lot about Neptune that we just couldn't know given how far away we were. And the solution to this was to send a probe up to Neptune to see it up close. The problem is that Neptune is really far away. The opportunity arose in the 1970s to actually do something. All of the gas and ice giants in the solar system were going to be aligned such that a probe could be sent to visit all of them and use the gravity of each planet to slingshot it to the next planet. On August 20th, 1977, NASA launched the Voyager 2 probe. Despite having a twin named Voyager 1, which was launched 16 days later, only Voyager 2 was sent on a trajectory which would take it past Uranus and Neptune. After 12 years in transit, Voyager 2 arrived at its closest point to Neptune on August 25th, 1989. It had actually started taking images of Neptune over a year earlier. Voyager 2 was on a flyby mission, meaning that it was going to zoom right past, taking as many photos as possible and making as many observations as possible before being slingshotted out of the solar system forever. What it discovered in its brief encounter with Neptune surprised everyone. For starters, despite being so far away from the Sun, the atmosphere of Neptune had the strongest winds in the solar system, 3 times stronger than Jupiter and 9 times greater than the strongest winds seen on Earth. Because Neptune was the last stop for Voyager 2, they took risks with the probe because it didn't matter where it went after that. The probe had its closest encounter with any planet flying only 4,950 kilometers or 3,080 miles above Neptune's North Pole. And it was discovered that Neptune had a magnetic field. Rings around Neptune were discovered in 1968, but Voyager 2 managed to discover several other rings which were too faint to be seen from Earth. Prior to Voyager 2, there were only 3 moons of Neptune which had been discovered. Voyager 2 discovered 6 more during its brief flyby. Since its encounter with Neptune, 6 more small moons have been discovered. Voyager 2 was also sent close to the surface of its largest moon, Triton. Triton is far and away the largest moon of Neptune, with 99.5% of all the mass of Neptune's moons. It was found that Triton had a surface consisting mostly of frozen nitrogen and water ice, and it also had a very, very weak atmosphere of nitrogen, which came mostly from frozen geysers erupting nitrogen gas. Given the brief nature of the flyby and its position relative to the moon and its daylight side, Voyager 2 only managed to photograph about 40% of Triton's surface. Voyager 2 remains the only probe ever sent to Neptune. There have been continued observations made of Neptune from Earth as better and better telescopes have been made. There are images of Neptune taken with the Hubble Space Telescope, but they still make Neptune appear to be a blurry blue ball. The James Webb Space Telescope has turned its eye towards Neptune and has been able to observe its rings quite well in the infrared spectrum. However, the Webb really wasn't designed for observations within the solar system. There are several proposals on the table for future missions to Neptune, but so far none of them have been approved. Most of the proposed missions are flyby missions like Voyager 2, but several are more ambitious. The proposed Triton Hopper mission would actually land a probe on the surface of Triton, and then collect frozen nitrogen to use as a fuel to allow the probe to jump from place to place on the planet. The nitrogen would be heated and put under pressure from a radioactive plutonium core, which would power the probe. The other ambitious mission is known as the Neptune Odyssey. This proposal is to put a satellite into orbit around Neptune, as well as dropping a probe into Neptune's atmosphere. As of today, no missions to Neptune have been approved. And even if they are approved, it would take about 16 years, given the current position of the planet, for a probe to reach it from Earth. So even if something were approved today, it is highly unlikely that we would be getting new images from Neptune before the year 2040. Neptune is a cold, distant world on the outer fringe of our solar system. For most of our history, we had no clue that it even existed. Nonetheless, it's proven to be a fascinating planet, and one that still has plenty of secrets to discover. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Thor, Thomsen, and Peter Bennett. I just want to thank everyone, including the show's producers, who support the show over on Patreon. If you'd like to support the show, just head over to patreon.com, which is currently the only place where you can get show merchandise. Also, if you want to talk to other listeners about the show, head over to our Facebook group or Discord server, both of which have links in the show notes.